Okay. All right, so today what we're going to see is module 8. And the question is your infrastructure well architected? Okay, that's one of the, of the things that as a solution architect, you have to consider how to architect an architecture, architecture the most efficient way. Okay, so part 1, what it has is an introduction to the well-architected framework. Okay, in other words, it's also known as WAF. The company I do some jobs for the NPN partner, they are all about well-architected framework. This is so important when it comes to AWS, very important. And then we're gonna see the pillars of that well-architected framework, and then the design principle of that, WAF. Okay. So upon completion of this module, you will be able to identify the 5 pillars of the AWS Well-Architected Framework, identify how the AWS Well-Architected Framework enables them to review and improve their cloud-based architectures, and reflect on the business impact of their design decisions. All right. So the Well-Architected Framework, the goal of this framework is to enable customers to do what? To improve their architectures, right? To see how the architecture is being built and improve it, right? And better understand the business impact of decisions when it comes to design. It provides a set of questions developed by AWS experts to help customers think critically about their architecture. Does the architecture follow best practices? So that's one of the questions that you have to ask yourself when doing this. Okay. So far, so good. So why should the AWS architects leverage this well-architected framework? So they do that if they want to instill, a habit of developing best practices in the companies that is using this. Okay, so they have to be more aware of the importance of well architecting whatever architecture they're trying to build. Okay. Also, there's some areas that are forgotten that people don't take into account, and they're so important. So they set aside and don't give them any importance. This addresses those areas, okay, that are so important. Okay. And also, they want to use some consistency when it comes to the principles that they use to assess these architectures. Okay. So the well-architected framework does not provide implementation details. It does not do that, right? It does not provide architectural patterns. It does not provide relevant case studies. What it does, it provides you with questions centered on critically understanding architectural decisions. So it would provide you with, like it said here, right here, it gives you a set of questions developed by AWS experts to help you think critically and get to a decision when it comes to design and the impact that design is going to have. Okay, so it also provides you with services and solutions relevant to each question. Whenever you have a question about a particular architectural feature, the well-architected framework will give you a recommendation of the services that you need for that, and also the solutions that you can implement to respond to that question. Okay, and also it gives you references to relevant resources. It will tell you where the resources are. Okay, It doesn't provide this, but it does provide the other three, these three here. Okay? So in other words, it's like an advisor that helps you think in a critical way so that you can answer important questions that you may have about your architecture. Okay? It will give you the response, it will give you solutions, and it will point you to where you can find the resources. Okay? Now, pillars of the well-architected framework. This is the beans and potato of this lesson. Okay? So don't forget these five. Okay? Operational excellence, deliver business value, security, protect and monitor systems, reliability, recover from failure and mitigate disruption, performance efficiency, use resource sparingly, and cost optimization, eliminate unneeded expenses. Okay, your business needs to operate excellently. Okay, it needs to be secure. It needs to be reliable, perform efficiently, and be cost optimized. So when you have these five pillars in action, then you can say that your architecture is well architected. By the way, the repetition of the word. Okay, so operational excellence, that involves the ability to run and monitor the system. Okay, to deliver business value. Okay, one of the things that people consider when you are presenting something or when you are being interviewed for a job or when you are, you have created something and then you want to introduce it to your supervisor or to any business owner, some things that they want to see, one of the things they want to see is the value that can give to the business. Okay, if it gives value, it is then usable and it's going to be coveted and wanted. But if it doesn't offer any value, so these people will not see any use in acquiring that product. Okay, so that's something from the business standpoint. It has to bring business value. Okay, so whatever you build, you architect. When users use your architecture, they have to know that you're providing business value to their business, just to speak. That's very important. And it has to continually improve supporting processes and procedures. So when you create an architecture, it has to be open for further expansion, right? It has to be open for further expansion. So you have to architect with that in mind, right? It has to support further processes and procedures, just in case they want to add more, they want to enhance the features or capabilities of that particular architecture. There has to be room for improvement. There has to be room for improvement. That's very important when considering operational excellence. Okay. Now the other one is security. Okay. So what are you going to secure in your architecture? You're going to secure your data, right? Your information. You're going to secure your systems, your software, everything that has to do with your VPC, your network, your databases. Everything has to be secure, right? And also the assets. So whatever things that you have stored in an S3 bucket, for example, like pictures or videos or any data that is important, you want to secure that. Okay, everything that has to do with the assets and speaking in the cloud, right? And while delivering business value through risk assessments and mitigation strategies. So you have to have some sort of a strategies to be able to identify the risks that you may run along the way, right? And be able to mitigate if something happens like a disaster or something. You have to be able to mitigate that. Or let's say that someone tries to hack your account. You have to be able to have some detection systems in place and some systems that can counteract and those attacks and be able to intercept them and then uh, resolve the issue as well. Because I think that if you only detect and don't take any action, I think that the process is incomplete. Okay, so those are things that you have to put in place when you are building your architecture. Okay, so far we have operational excellence. You have to deliver business value, right? Business value and continue improvements, right? And then also you have to secure your information, your systems, your databases, your assets, your servers. Everything has to be secure, right? When I talk about servers, I'm talking about virtual servers like EC2. You have to put some firewalls, some security groups there. You have to have some NACLs in your subnets. You have to have some logging, like if VPC flow logs. You have to have some CloudTrail there and CloudTrail logs. You have to have some CloudWatch. Everything has to be working just as a unit, so you can have security in place, right? Also, your system has to be reliable, right? It has to be reliable. What is reliability? Is the capability of being able to run and be operational even in the presence of a failure. Okay? So recoverability is very important and in any system, right? You have to be able to recover from infrastructure or service failures. Okay, we've been talking about that very repeatedly. We've been saying that you should start your architecture with minimum 2 EC2 instances, minimum 2 availability zones. We said that the amount of EC2 instances is going to be based on the availability zones that you have. You have 3 availability zones, so the minimum amount of EC2 instances should be 3. You should have, if you're global, you should have some, global infrastructure, like Route 53, CloudFront, those guys, edge locations in place so that you can be able to recover when something happens. If one region goes down, you already have another region in place, waiting there to be for the data to fail over to that region. So this is very important. Okay, that's very important. And you have to be able to dynamically acquire computer resources to meet demand. Okay, we've been talking about that. When with auto scaling, whenever you need more resources, it will increment the amount of resources. When demand is low, it will reduce the amount of resources. So this is something that has to be there, and that's what makes a system reliable. Okay, you can have disruptions, like, for example, misconfigurations. And this morning we spoke about a service that is a AWS config. There's a change in configuration. Something is not compliant with your architecture, and you can mitigate that, right? So you have some services that will tell you there's a problem with the configuration, and that you can mitigate that. Okay, or you may have temporary network issues, like, for example, your VPC is having some issues. There's some problems with the security groups of one of the security groups is not doesn't have an open port, and then you can just have AWS config that would tell you that there's some ports that are not open. They're supposed to be open, or there's some ports that are open and they're supposed to be closed. So there's some temporary network issues that you may have. It's going to be like connection or something, but when you're reliable, you can solve all this, and you can continue of running your services. Okay. Another one is performing efficiency, okay, which is the ability of use computing resources efficiently to meet system requirements. Like we have said before, sometimes you have more resources than you need. Like you are over provision, right? You're over provision, and then you need to be, you need to have the services that you really need, right? You don't need to, you don't want to have more than you need or less than you need. So um, performance efficiency is part of that. It's using resources sparingly, right? Based on the requirements, whatever your system needs. Maintain that efficiency as demand changes and technologies evolve. So this is very similar to um, this guy here, to reliability, right? Dynamically acquire computer resources to meet demand. They're all, together, working together, right? So an efficient service or system is the one, like I said before, it has to be open to new changes because technology evolves every day, right? Every day people are creating new things, right? And your system has to be able to evolve over time. A system that is not um, up to the standards of the changes that are happening right now is a system that is doomed to disappear because if you don't have updates in place, if you don't have new features in place, if you don't have more compatibility with new resources that are being created, new system, new software, your software is condemned to disappear. Okay, what do you think that Apple is constantly creating new updates, right? If you have an iPhone or any Apple product, I'm not sure about Windows because I don't have any Android um, phone or anything, but I'm sure they have updates too. Of course, they have to. Every now and then you see there's a software update with your iPhones or Mac OS devices. And when you read what the update is all about, it says that this update will fix this bug or will add new features or will just fix the problem that we have with this. They're always keeping up with with the technologies that are happening right now. Even though I must tell you, for some reason, I don't know if you're a Mac user, but for some reason, sometimes Apple makes updates that all phones cannot deal with. They cannot cope with the updates, and then you will have to buy a new phone for some reason. So as time goes by, your product becomes more and more, sluggish. It becomes really slow, and then you get to a point where it says, "I cannot deal with this anymore. If I want to continue with Apple, then I have to buy a new Apple product." So I think that they do it on purpose. They do it on purpose because I have experienced that. I've had to buy a new Apple product because simply the one that I have currently is not strong enough to cope with this massive changes that Apple is just making on their versions. So your system, whatever system you're implementing, whatever architecture, it has to leave room for improvement. There has to be some little door there that allows in some changes that other third-party technologies are making. So that's very important. That's part of the performance efficiency. You want your website to be fast. You want your software to be efficient. So that's why you have to, evolve it. You have to change, right? And the last one is the cost optimization. This guy is super important. That's one of the questions that people ask themselves when they want to make a move in life. How much is it going to cost me? When it comes to business, how much is it going to cost me? And this is one of the things that make people skeptical when they're moving their infrastructure on premises to a cloud provider. Okay, how much am I saving? Is it worth the move? Is it worth? What's the difference? How much money am I going to save? Okay, so but with this cost optimization, you have the ability to avoid or eliminate unnecessary costs. So it's like we said before, this guy will tell you, you know, am I meeting the requirements? Am I over provision, under provision? And this guy will tell you, well, if you're over provision, then you're paying more than you're supposed to, right? So I'm gonna give you a service, right? With this service, which is auto scaling, right? This is one of the services that you can use. That service is gonna help you eliminate unneeded costs, okay? If your demand is high, I scale out. If your demand is low, I scale in. Simple as that, okay? And also you can eliminate suboptimal resources that are not optimized. So you can eliminate them. So they're not completely helpful. So I will just eliminate them and keep the ones that are really gonna help me. So we have auto scaling, but we have all the resources, right? If someone hears the morning, what is the service that can give you recommendations for saving money, for security, and things like that? What is that service? No one here from the morning? What is the service that I can use and gives me recommendations for different services?
Trusted advisor. Sorry, nobody answered. So I try to take my be quiet. So.
Okay, so that's the service. So you can use, what's the service that can help you have a projected bill? You can see a projected bill in the next 3 months, and you can go back up to 13 months. What's that service? No? Cost Dora the Explorer. Cost Explorer. Okay? That's a service. What is the service that helps me know how much my infrastructure is going to cost before I move to the cloud?
Total cost of ownership.
Right. And what is the service that's going to help me know my monthly bill? Another one, right? That's simple monthly calculator. So those are services that you can use to optimize your cost, right? But when you have all these guys, the 5 guys that we spoke about, okay, what are they? Operational excellence, security, reliability, performance efficiency, and cost optimization. When you have that in place, then you can say that your infrastructure is well architected, okay? And everyone has a bunch of services associated with them, okay? So services that we can use, for example, here, you know, this is from a business perspective, but this one, for example, we can use a lot of services for this, right? You can use a service at an instance level, or at an instance level. You can use services at a subnet level. You can use services at a VPC level. You can use services at outside the VPC. You can use services, so many services that cooperate. You can use IAM as well, which is a global service. You have so many services that come together and make your infrastructure so highly secure. So for reliability, we can have, you know, this multi-AZ thing that we have thought about all the time, you know, that's high availability thing, right? That you're able to continue running when something happens. For these guys, you have auto scaling. You have all these guys that meet your meet your demand. And for this guy, you have so many services that can help you with cost optimization. Okay, so this is so great, right? What are the principles? Okay, so the well-architected framework also identifies a set of general design principles to facilitate good design in the cloud. For some, stop guessing your capacity needs. And if you remember well, this is one of the what have does it sound familiar if I tell you the 6 benefits of the cloud? Does it ring the bell? The 6 benefits of the cloud? Remember? Trade capital expenses for variable expenses. Remember? Massive economies of scale. Remember? Go global in minutes. Stop guessing your capacity needs. Don't remember? That's going to be your cloud practitioner exam for the students in the morning. So systems are production scale, automate your to make architectural experimentation easier. This is the ultimate goal of every single DevOps engineer. Okay, and the DevOps engineer doesn't architect that much, right? But an architect has to be able to automate things too. Okay. You have to allow for evolutionary architectures. That's what I said before. You have to allow for changes and improvements, things that are going to change, new features, enhancing a feature, things like that. You have to drive architectures using data. Okay. Data is very important. Big data, that slogan says, it's all about the data. Okay. Improve through game days. Game days is, do you guys know what a game day is?
No idea.
Am I talking to myself?
No, but what is a game day? I have never heard of this.
Never?
No, ever.
Okay. So game days are days that Amazon or companies can use for their employees to test their abilities in the cloud. Okay. It's similar to a hackathon. Okay.
Oh, interesting.
So game day.
I've seen intercompany hackathons, but this
Game day is an interactive team-based learning exercise designed to give players a chance to put their AWS skills to the test in a real-world, gamified, risk-free environment. Most importantly, it is an extremely fun way to learn more about the potential of AWS without the step-by-step instructions provided in workshops or classroom-style sessions. If you're seeking an open-ended and at times ambiguous style of training, then game day is the perfect challenge for you. Okay. Okay. So these are some of the game days, upcoming events, free event. I will be here. But it depends. I already spoke to the company I work for, the APN partner, and they want me to be there. So this is free. Do you know how much this is? You have an idea, guys? It's a 3-day event, and it's $2,000 for this. So if you're affiliated to an NPM partner, you may get this for free, right? And that you're gonna interact with people that work for AWS experts, and it's super, super, super good. No, I hope to go there if this coronavirus thing changes. Well, it seems that's gonna change.
I thought it was.
They said that probably the vaccine is gonna be available at the end of the year. So I hope that I will be able to go there. That's my desire. So stop guessing your capacity needs, traditional environment. when you make a capacity decision before you deploy a system, you might end up wasting expensive idle resources or dealing with the performance implications of limited capacity. So you can go either both ways, either too many resources or too few resources. So this is the bad thing about traditional environment. But if you are in a cloud environment, you eliminate guessing your infrastructure capacity needs and use as much as or as little capacity as you need and scale up or down automatically. So guys, I don't need to repeat myself. You already know this. Okay? This is AWS 101. All right? The test systems at production scale, it is usually cost prohibitive to create a duplicate environment solely for testing. It doesn't make sense, right? I mean, in a traditional environment, it doesn't make sense, right? And most test environments are not tested at live levels of production demand. Of course, they're done in development. Okay. Now, in the cloud environment, you create a duplicate environment on demand. Complete your testing and test the commission the resources, and then the commission the resources if you don't need them anymore. Only pay for the test environment while it is running. So you can simulate your live environment for a fraction of the cost of testing on premises. So the cloud gives you the capability of testing in a live environment, which you cannot do or you don't usually do in a traditional environment. All the testing happens in development, okay? In development, and also in user acceptance, in the user acceptance phase, okay? When you create a product, right, you test it, right? You test it, and it goes through different phases, okay? Now, when it gets to the user acceptance testing, is when the user tests the product, right? It can be a stakeholder, it can be a client, it could be a consumer. So they test it. And then they get back to the developers with feedback, right? They tell them if they meet the requirements. If they don't meet the requirements, and then you can continue working on that. And if everything goes well, then you go and put your product in production, okay? Where the entire world is going to use it. Okay. So all of the testing, most of the testing here happens in that phase, and before that phase, and then that phase, and then, you know, live production is at the culmination of the testing. Okay. But with the cloud environment, you can test it during the live environment. So automate, to make your architecture experimentation easier. On premises environments, you have several structures and components that require more work to automate. No common API for all parts of your infrastructure, okay? But in the cloud, you can create and replicate your systems at low cost, no manual effort. That can be automated, right? And track changes to your automation, audit the impact, and revert to previous parameters when necessary. When something goes wrong, what you can do, you can roll back to previous versions, okay? So you don't have any problem with something, you know, is changed or anything, or something breaks. Allow for evolutionary architectures. Architecture decisions are often implemented as static one-time events, right? There may be only a few major versions of a system during its lifetime. And as a business changes, initial decisions may hinder the ability to meet changing business requirements, right? When you make decisions at the beginning, it may limit, you know, evolution of your software or system, you know, as you go, right? It all depends on when you start here, what's your design, right? Now in the cloud environment, you have the capability to automate and test on demand. It lowers the risk of impact from design changes, right? So when you automate this and test it on demand, you can make all the changes you want. The risk is very low. All right. and it's on demand. The good thing, the difference between this and this is that when you make decisions at the beginning of this decisions that you make, um, it might, like it says here, might limit your changing requirements in the future. But here it's on demand, right? So you don't have any problem with that. Now, system can evolve over time. We know that already. Technology evolves, so do systems. Then the business can take advantage of new innovations as a standard practice. Okay, with the cloud, you have that capability, right? Drive architectures using data. In the traditional environment, architectural decisions are often an area that is chosen according to organizational defaults. Okay? And data sets generally cannot be generated. Generally, it doesn't mean that always, right? Models and assumptions to size your architectures are probably used. Okay, these are some assumptions that you may have in a traditional environment. This is not necessarily 100% true, right? But they use the correct words here. They use often here. They use general here, and they use assumptions here, and probably. Okay, so this is not 100% on stone, written in stone, but it is some limitations on issues that you may have when you have a traditional environment. Whereas in the cloud, you collect data on how your architectural choices affect the behavior of your workload. Okay, and you make fact-based decisions on how to improve your workload. So you're gonna assess the facts and all the things that are happening, and then based on that, you make decisions to improve your workload. Right? You use that data to inform your architecture choices and improvement over time. Okay, it's like, for example, now some people ask the doctors that are in charge of this workforce department for the coronavirus, and they always use this word: we need the data, we need the facts, so that you can improve your strategies or have some models and things, right? So you can drive your architecture using the data. So you can improve through game days, right? You would allowed only exercise your run book when something bad happens in production. Okay, like, remember, we test in development, right? A development here, and then when something goes back in production, because many things can go bad in production. What happened to Toyota Camrys a few years ago? There were some people that died, right? Because I guess the accelerator got stuck, and then people couldn't brake, they couldn't stop the car, and then there were some accidents and people die. So in Toyota, what they have to do is just had a recall, and all the models and years of that particular car, they called them in, and then they had to make some repairs, right, for those accidents not to happen anymore. But some people say that Toyota already knew that. They just wanted to test, or probably they didn't test it before, and they just introduced the car in the market, and let's see what happens. Some people say that they do that brutally. I mean, that way, unconsciously. I don't know. They don't heartlessly. I don't know. But it happens in production when the car is already being used, right? Now in the cloud, you can test your architecture and processes performed by scheduling game days to simulate events in production. So you can simulate a live environment, and then see how it works, how it performs, right? Using game days, right? Understand where improvements can be made and develop organizational experience in dealing with events. I'm sure that things that you do in the cloud, you can also do in the traditional environment, right? But we're just trying to see the benefits that you have when you move to the cloud. Okay, there are tons of companies that they're still on premises, right? and they're doing well, right? But I believe that they would do much better if they move to the cloud, right? Especially when it comes to costs. Okay. So in review, we learn how to assess, improve your architecture, identify the key features and benefits of the well-architected framework, and discover design principles to facilitate good architectural design in the cloud. Now, you may say, Professor, but we saw the pillars so briefly. No, students, there's gonna be a PowerPoint and a module for every single pillar. Okay, so as we go in the course, we're gonna see every pillar one by one. So we're gonna speak about each one by one. All right. So the next one for next class is gonna be pillar 1, operational excellence. Okay. So do you have any questions? I have one for you. What are the 5 pillars of the well-architected framework?
Operational excellence.
Good. Another one. Another person, please.
Security.
Security. What else?
Reliability.
Reliability. What else?
Performance efficiency.
Performance efficiency. And the other one?
Cost optimization.
Money. Okay. Students, do you have any questions? It was a short lecture, right? Because now we're going to take an exam. Do you have any other questions? I don't think you do. It was easy, right? Easy to understand. So I'd rather take a short break now, right? And start the exam later because we don't want to interrupt the exam. Okay? So
are we doing a group exam or are we doing?
It's a group exam.
Oh, okay.
It's a group exam. So let's take 10 minutes break and let's be back here at 1:55 so that we can take the exam. Okay?